Empirical formulas are nice, but being able to calculate the actual molecular formula is even better. The molecular formula, like we mentioned earlier, is always a whole number multiple of the empirical formula. And so we need to find out what that whole number is. What do we multiply the empirical formula by? The way you do that is you need to be told what the molar mass is. That's not something you can figure out because you don't know what the formula is. So we have to tell you what the molar mass is. Now, experimentally, the way you do this is you would use an instrument called a mass spectrometer, and you can figure out the molar mass of the compound that way. And so you can determine that experimentally. But, we're not going to do that here, so they'll always tell you what the molar mass is. Then you figure out what the empirical formula molar mass is. That empirical formula that you just calculated, calculate the molar mass of that, and see how many times it fits into the true molar mass. And that will come up to be a nice whole number unless you calculated your molar mass incorrectly. Does that make sense, or does that just sound like more weird stuff? Sometimes I feel like Charlie Brown's teacher. Okay, enough of you have actually seen the Charlie Brown cartoons. Blah, 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 blah. And people are just sitting here kind of eyes glazed over looking at me. It's okay. I don't take it personally. So let's say we had a box. And we know that there's bowling balls in that box. And we know that this box weighs 100 pounds. How could we figure out how many bowling balls are in there without actually opening up the box and counting them? If we knew the weight of one of the bowling balls, right? So if we know the mass of one bowling ball is 10 pounds, how do we figure out how many are in there? We take 100 and divide by 10, and that tells us there's 10 balls in that box. This is the empirical formula. You need to know how much the empirical formula weighs. The whole thing is the molecular formula. The molar mass of this will be given to you. You figure out how many of these are in there by dividing. Does that make more sense? So let's do it. Compound containing phosphorus and oxygen has a molar mass of 219.9 grams per mole and an empirical formula of P2O3. Determine its molecular formula. So this is the bowling ball, and this is the box. And we need to figure out how many of these are in the box. The box weighs 219.9 grams. How much does each of these weigh? Can we calculate that? Sure we can. So we have 2 times the mass of phosphorus and 3 times the mass of oxygen. I told you, we calculate molar masses a lot. We've already done it 10 or 15 times just in this lecture. 2 times 30.97 plus 3 times 16 equals 109.94. That's grams per mole. That's how much the individual piece weighs. And we want to find out how many of them are in the molecular formula. So we take the mass of the molecular formula, 219.9 grams per mole, and we divide by the mass of the empirical formula, 109.94 grams per mole. And we get 2. That tells us there's 2 bowling balls in the box. There are 2 of these in the molecule. P2O3, there's 2 of them in the molecule. But that's not how we write formulas. We need to multiply it through. So we're going to multiply all the subscripts by this number that we found. We're going to get P4O6. That's the actual molecular formula. And you can check that by calculating the molar mass of this and see if you get this. You will. Any questions? Look, we're at the end of chapter 6. Sweet. I think anybody listening to these screencasts must think that we are attending school in the middle of a train yard. That's what it sounds like. There goes another one.